Good morning, everybody. This is lesson number 2 on solving absolute value equations. Just to remind you, we can expect to have 2 solutions. There's a possibility of one solution, and there's a possibility of no solutions. We're doing some problems where it's just maybe a little bit trickier to get the absolute value isolated. We're going to keep this lesson a little bit shorter with only 4 examples, but I think this will help you transition into our second assignment on absolute value equations quite nicely. So we're going to jump straight into problem 1. We have 3 times the absolute value of x minus 2 minus 4 equals 8. We're going to need 2 equations. But remember, step 1 must be to isolate the absolute value. There's 2 things going on. It's being multiplied by 3, and 4 is also being subtracted from it. So the first thing we want to do is isolate the term that has the absolute value in it. That involves adding 4 to both sides. If you divide by 3 as your first step, this will be really rough. The algebra is going to start to get fractions which we're trying to avoid. So this gives us 3 times the absolute value of x minus 2 equaling 12. The absolute value isn't by itself yet. There's a 3 in front. So if I were just to divide both sides by 3, can you see that those 3's will cancel? And now we have that important thing done. That absolute value is isolated. Now this problem has become just like the ones that we did on lesson number 1. This is where I switched to 2 equations. If what's inside the absolute value is equal to 4, we have solutions. If what's inside the absolute value is equal to negative 4, we also have solutions. So it's this step that we just get used to, but it can only be done after the absolute value part of the equation is isolated. So here, to get x by itself, I'm adding 2 to both sides, giving me x equals 6. Over here, I'm adding 2 to both sides, giving me x equals negative 2. Notice these 2 answers are not opposites of each other. They will only be opposites of each other in the simpler equations. You shouldn't expect these 2 answers to be plus or minus 6 or plus or minus 2. That only happens on the easiest problems. Here, our 2 answers are negative 2 and positive 6. Example 2. I need to get the absolute value by itself again. Don't divide by 5 as your first step. We're going to add 10 to both sides as our first step. So adding 10 works beautifully. We now have 45 equals 5 times the absolute value of x plus 6. To get that absolute value by itself, divide by 5. Now we have the equation 9 equals absolute value of x plus 6. And here we are, just like the problems we did yesterday. If what's inside is equal to 9, we have a solution. But if what's inside is equal to negative 9, we also have a solution. So I'm going to subtract 6 on both sets of equations to isolate x. So here I'm getting 3. And here negative 9 minus 6, that is negative 15. So be very careful with those. Double check those with your calculator. I'm getting negative 15 comma 3. Make sure you are not using parentheses here. Because parentheses makes it look like an x-y combination, and that's not what we're finding. Both of these answers are x values, so it's important to use the squiggly brackets. Okay, 2 more. Same thing as before. To get the absolute value by itself, I'm going to add 9 to both sides. We have a 6, and then an absolute value. And on the right, I think we have 66. So to get the absolute value by itself, we're getting rid of that 6 through division. Just like the 2 problems we did, 1 minus 5x in absolute value still equaling positive 11. This looks like a problem that's going to end up being fractions, but I don't know that yet. I'm switching to 2 equations, 1 minus 5x equals 11, or 1 minus 5x equals negative 11. I need to subtract 1 from both sides. That gives us the equation negative 5x equaling 10. If I divide both sides by negative 5, I'm getting It's not a fraction or a decimal, but it very well could have been. To get the second answer, I'm going to subtract 1 from both sides. That gives me negative 5x equals negative 12. Okay, this does look like it will be a fraction. If I divide both sides by negative 5, negative 12 divided by negative 5 is positive 12/5. So one of our answers turned out to be a nice clean number and the other one is a fraction. I will display my answer this way. Negative 2 12/5. And now for our last example. To get the absolute value by itself, we have a 4 on the bottom here and 2 is being subtracted. So we want to get this term by itself first, so I'm going to add 2 to both sides. This gives us absolute value of 2x plus 1 over 4 equals 9. So here we're not going to divide to get the absolute value by itself. We need to multiply because that 4 is on the bottom. So I'm going to multiply the left side by 4. I'm also going to multiply the right side by 4. And those 4's will cancel. And notice my absolute value all by itself. The number on the right is 36. So now we're ready for our 2 equations to get our 2 answers. If what's inside is equal to 36, we're good. If what's inside is equal to negative 36, we're good. So to finish this problem off, I'll subtract 1. That gives me 2x equals 35. And after I divide by 2, it looks like we're getting a fraction. I think this is the same thing as 17 and a half. Over here, I'm going to subtract 1 from both sides. That's 2x equals negative 37. And if I divide both sides by 2, I will get negative 37 over 2. In the interest of time, I'm not going to put them in the squiggly brackets, but this one is 17.5, and I think this one is negative 18.5 as a decimal. But leaving them in fractions is just great. Hopefully this helps you on assignment number 2.